Hello, first of all, thank you for inviting me to this summit. I had been so looking forward to meeting the brilliant students of Brown University in person. However, at this point, it is more important to keep maintaining social distance to protect the more vulnerable people in our society, and I'm happy to share my thoughts in this way. My name is Eunsu Kang. I'm an artist, a researcher, and an educator, exploring the intersection of art and machine learning. In this time of pandemic, I cannot stop thinking of the benefit of good statistical predictions as well as automated services that would help people stay safe. At the same time, we are deeply moved by people's creative actions as a source not only of consolation but also of inspiration for our future. My talk, In Search of Creative AI, will have four parts. First, the era of AI art, mind-blowing and controversial. Second, at the intersection of art and machine learning. 3, briefly exploring questions such as, can AI be creative? And 4, can AI collaborate with artists? In the era of AI art, what's been happening? 2017 June, the generated art images by creative adversarial networks, CAN, were favored by human viewers over the images of paintings at the prestigious Miami Art Basel. In 2018, Cloud Painter, which was a top prize winner of the International Robot Art Competition in 2018, proved that a machine can achieve the aesthetic level of professional painters. 2018 October, a painting that was generated by the standard GANs was sold for over $400,000 at auction by Christie's. 2019 and 2020, AI is everywhere in art, including dance, literature, music, poetry, and sculpture. At the intersection of art and machine learning, my collaborators and I have generated authentic sculpture forms. These 3D forms do not mimic any given forms and cannot be easily categorized into the labels of the training data set. For that, we have developed machine learning algorithms. Amalgamated Deep Dream is a point cloud generation algorithm that is inspired by the 2D image generation algorithm Deep Dream. The shape goes through iterations of feature amplification. The naive approach we first tried resulted in sparse point clouds that we would not be able to turn into solid sculpture. We came up with methods such as uniting different point clouds to have a denser point cloud that we could use. Furthermore, partitioned Deep Dream segments a point cloud, and each segment goes through iterative feature maximization. We were able to generate aesthetically interesting forms. After both pivoting mesh reconstruction, those forms were 3D printed using a large spot TOS6 dual head printer. We tried different methods as well. From the first algorithm development, we found out that it is extremely difficult to generate a point cloud that is printable, while we aim to have artistically unique and original forms. We tried a few new methods that would transform point clouds without losing much information. One of them is this method using the sphere prior. This algorithm observes how the mesh sphere transforms into another form. To transform a point cloud sphere into a new form, the algorithm would use its correspondence in mesh transformation. The other method, learned interpolation, we have used to create this video. Our idea for the future development is to create a video that represents forms in a story that is also written in collaboration with the machine learning algorithm, like this. Our sculptural objects have been exhibited as an interactive art installation. The creatures are imagined by our machine learning algorithm, Amalgamated Deep Dream, ADD, and Partitioned Deep Dream, PDD, which I presented a few minutes ago. These unknown creatures are named oral fauna for their unique behaviors. They react to the visitor's sound or touch. In other words, this family of unknown creatures becomes alive when there is a sound or a touch fed into them. Here is a little video of oral fauna.
Hello? Who are you? Are you oral fauna?
So we have tried to make creative algorithms. However, this question have not been resolved. Can AI be creative? As an investigation into this question, my colleague Dr. Jin Oh and I co-taught the class Creative AI at the Machine Learning Department of Carnegie Mellon University last fall. One statement that can be commonly agreed upon in the world of modeling creativity computationally is that you can produce results that are both novel as well as high quality in the domain. To make an algorithm creative, we would need a narrowed down definition of creativity. We studied several theories studying creativity, for example, Newell, Shaw, and Simon's insights from 1958 that includes completely operational specifications programs for the behavior of mechanisms or organisms that with appropriate initial conditions would in fact think creatively. A demonstration that mechanisms behaving as specified by these programs would exhibit the phenomena that commonly accompany creative thinking. A set of statements, verbal or mathematical, about the characteristics of the class of specifications programs that includes the particular examples specified. Also, Boden's definition of creativity, such as combinational creativity that produces unfamiliar combinations of familiar ideas, and it works by making associations between ideas that were previously only indirectly linked. Or transformation creativity. It can give rise to ideas that are not only new but fundamentally different from any that went before. More studies we had helped us to understand the process of modeling creativity better and define what kind of creativity the project or algorithm was aiming to achieve. Yet, of course, some questions remain. Can we computationally model ambiguity? Ambiguity is one of properties defining the area where the creative evolution happens in the domain of visual art. And would the novelty search result in a valuable discovery? We were studying Ken Stanley's novelty search. Where is the threshold between randomness and creativity? It's a very difficult question. How do we evaluate the creativity of an algorithm? This evaluation metric doesn't exist yet, so we conducted some experiments for setting up evaluation metrics for creativity of a creative algorithm or machine learning art projects in the class. Although such a human-centered method is subjective, participants, our students, found that the exercise helped them to better describe and interpret dimensions of algorithmic creativity. Sorry. In the search for creative AI, we probably need to travel a long path. This famous machine learning and cosmology research done by brilliant scientists can generate a universe. One of the challenges they have not conquered yet is to figure out a way of generating rare galaxies or other interesting objects or events in the universe. They hope to generate samples from the tails of the distribution where, I think, the novel features could be found. What would be the algorithm that can do that? If this is solved, I believe we are one step closer to exploring creativity of machine learning algorithms. And what does it do to us? Why does it matter to search creativity in AI or using AI methods for creative projects like art? I found an insight in the game of Go. The Go field has changed a lot over the past few years. Many Go players now train themselves against AI Go programs. AI Go programs suggest novel strategies and provide abundant amount of practice. As a result, their average level of skill has increased. I believe this could happen in the world of art and culture as well. AI could inspire, assist, and possibly collaborate with people. Can AI really collaborate with artists? We actually, the short answer would be no, but there is a possibility. To verify that, my student colleagues and I did a bit of study. What has been meant by collaboration in art? It is a profound mutual effort that creates a third artistic identity superimposed over and exceeding the individual artists. We can change this artist into scientist or just people or any kind other type of positions. After evaluating several projects at the intersection of art and machine learning, we concluded that for now the collaborator is the machinic surrogates that are proxies for skills, decisions, and biases of human agents who are involved in developing and running such algorithms. We call these people also human inspirers. Human-machine relationships in computational creativity can be observed as this diagram. Humans here can be an author user, a user, a moderator, or an audience depending on their roles in the process. Please note that this is a spectrum and one person could take multiple roles. From this perspective, we analyzed the human roles in the production of the portrait of Edmund Bellamy. Human agents here are Ian Goodfellow. I'm very sorry that his name is misspelled here. It's Good Fellow. And his team, my apologies, Ian Goodfellow. And his team developed the GANs, generative adversarial networks. And then Chintala, who implemented it to DC GAN, Then Barrett, who made another implementation, ArtDis again. Then the OBS team downloaded and applied the portrait dataset. Art auction experts at Christie's and the audience bought the concept of AI art. So all these people were involved in turning this image into an artwork that's accepted, quote unquote, in the art field. As you can see here, sorry about moving one slide over, the authorship as well as ownership of these AI artworks that are created by human agents and machines are very complex and difficult to clarify. So much work to do here, but we keep moving towards the future where we may have creative AI and might collaborate with it. To finish up this short presentation, I'm sharing an excerpt from a duet performance by human and machine-generated creatures that happened this February in San Diego. Thank you. So many of these studies I presented today are either on my website or you can find our research papers on arXiv website. And please don't hesitate to contact me for any questions. Thank you. Stay safe and healthy. Bye-bye.